So students, our next lecture on instantaneous sender, we will discuss the how to locate the instantaneous sender of a 6-bar mechanism. So the common mechanisms what we have to concentrate are 4 link mechanism and 6 link mechanism. So 4 link mechanism we have two mechanisms. That are the basic mechanisms. You have 4-bar mechanism and Snyder-Gang mechanism. So in both ones we understood how to locate the instantaneous sender. Now we will see a instantaneous sender location for a 6-link mechanism. So a mechanism is shown here. First check whether it is having 6 link or how many links you have. Just count. We have the fixed link, 3 points you can see. Here we have a fixed link, here we have a fixed link, here the slider path is also fixed. So we have all links we will consider as one only. So fixed link as 1. Then we have OA. OA is supposed to be the crank or rotating part of the mechanism. That is your second link. Then we have a one link AB connecting to crank. Then another one BC. That is your fourth link, and you should see that BC is oscillating or rotating about E. Okay, it is not, these are not two links, this is the same link BC which is hinged at E. Then we have fifth one is connector to from BC to slider, that is this link CD. Finally we have slider. So we have 6 links. This is a 6-link mechanism. Now we'll see how to locate the instantaneous sender. So first you determine how many instantaneous senders are there for a 6-link mechanism. So the equation is n equal to capital N equal to small n into n minus 1 by 2. When you apply 6-link mechanism, we can say 6 into 5 by 2. 15 is the count. Okay, so we have a total of 15 instantaneous sender. So we will try to locate all the 15 senders. Then you will understand how to locate. Okay. First first you note down all the senders. So we have 6 links. Then how can count the senders? We can say between 1 and 2 there will be a sender. 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Then between 2 and 3, 2 and 4, 2 and 5, 2 and 6, 3 and 4, 3, 5, 3, 6, like that. You write all, list all the senders. Okay, just listed it. Just only mention the links, not the I representation should be there when you represent I12, I13, like that. Okay, so we have these 15 senders. Let's go through that. So then we'll one by one we'll locate. First part is primary senders that we have to locate by the direct inspection of the mechanism or space diagram. So where will we start? We have 1 and 2. So 1 and 2 is joined at O, so that is your first sender, I12. Okay, then now we have 14 sender, so keep on moving. Then we have 2 and 3 joined at A, so we have I23. 3 and 4 joined at B, so we have I34. Then C, 4 and 5 are joined at C, so I54 will be at C. Then see this link. The link 4 is connected to link 1. Okay, this is again a fixed link. So at E, link 4 is connected to link 1. So that is equal to what? I14. I14. Then we have 5 and 6 joined at D. So that is I56. Finally, slider is there. So instantaneous sender of slider or slider is represented by 6. So I16 is at infinity because it is moving in a sliding motion. So the rotation can only be considered when we consider the sender as infinity. So you represent it, put an arrow and write I16 at infinity. So these are the senders we can locate by the direct inspection. Next we will see how to locate remaining sender. So first common sender we can take 1, 3. So how will you locate 1, 3? So the previous combination, same combination you can remember. 1 3 means 1, you can take the combination 1 2 3 and 2 3 4. So we can say the line joining 1 2 2 3 and 1 3 will be same line. Similarly 1 4 3 4 and 1 3 will be on the same straight line. So you do that, draw extend 1 2 2 3 and extend 1 4 3 4. So that point will be your I13. Then we can locate 2 4. How will you locate 2 4 in a 4 bar mechanism? The 4 bar mechanism 1 3 and 2 4 you already located. That's why I started with 1 3 and 2 4. So 2 4 you remember in the previous question. We can locate. We can join 2 3 and 3 4 and 1 3 and 1 2 and 1 4. Okay, so you can join 2 3 3 4 and 1 2 1 4. So 2 3 and 3 4 are already link AB. So if you join it, it will be same link AB corresponding to link AB, and you join 1 2 and 1 4. So 1 2 and 1 4, 1 2 is this point, 1 4 is this point, joined with a straight line. So this both lines meet at this link inside the along the link itself. That is your I24. Okay. So next we have we can locate. So you see next we can locate 1 5. So this how will you locate 1 5? To locate 1 5 you have to take any combination of 1 5 with the third link. So you can take a combination 1 5 6. Before that you have to make sure that when you take a combination of 1 5 6, the other you will get 3 instantaneous centers. So one will be 1 5, so other two will be present in the diagram. Okay, if it is not present in the diagram we cannot determine. Therefore the one in present in the diagram should be taken. So if I take 1 5 6, we have 5 6 and 1 6. So if I take 1 5 6, the centers will be 1 5 1 6 and 5 6. So I have 1 6 5 6 and 1 5 will be on the same straight line. So this will be a line to infinity. So this line, so we will see the next combination. Next combination, which one you can take? You can take 1 4 5. Okay, you take 1 4 5 combination, then what we can say is 1 4 4 5 and 1 5 will be on the same straight line. Here we have 1 4 at E and 4 5 at C. So the extension of this will be result in the same one location of 1 5. Now if you extend in this direction, this is going to infinity and this is also going in this direction, it will never meet. So the only possibility for the center is on the other direction. So you have to extend this line downward, the infinity direction line you have to extend downward, and the other one you are also extend. It should meet. Okay, here it is not meeting, don't consider that. Whatever you have to extend it to meet, so that point you can will be your I15. Okay, then next you can take 2 5 or 2 6 or 4 6 you can take. You take 4 6, I think I mentioned 4 6 only. Okay, so if you consider for 4 6, the combination you can take is 1 4 6 and 4 5 6. If you consider 1 4 6, the combination centers are 1 4 4 6 and 1 6. Then if you take 4 5 6, centers are 4 5 5 6 and 4 6. So 4 6 is common to both. So we have 4 5 and 5 6. The CD is 4 5 to 5 6 line, so you can extend it. Then other one is 1 4 1 6. So 1 4 should be joined with 1 6. So 1 6 is at infinity. Therefore, how will you join 1 4 with 1 6? Just to draw a line to infinity. The same thing. Okay, copy to here to 1 4. So 1 4 and these two lines are meet at this point. This point will be your 4 6. Okay. And next we will see 2 6. To locate 2 6, take two combination. You see which combinations you can take. 2 6 mean possible combinations are 1 2 6. If you take 1 2 6, you should have 1 2 1 6 and 2 6. That is possible because 1 2 is here, 1 6 is infinity, we know. So 1 2 1 6 and 2 6, that you can take a one combination 1 2 6. Then next combination, which one you will take for 2 6, you can take after 1 you can take 2 3 6. When you take, if you take the combination 2 3 6, then 3 6 is not located, so you cannot take. Then you can take 2 4 6. If you take 2 4 6, you see here 2 4 is located. 2 4 6 means use this here, this diagram also for reference. You located 2 4 and 4 6. So if you take the combination of 2 4 6, the centers will be 2 4 4 6 and 2 6. So 2 4 and 4 6 already there. So first combination is 1 2 6. So 1 2 is there, 1 2 is located, 1 6 is located. So we can locate 2 6. Now you join 1 2 and 1 6 also 2 4 and 4 6. So this line, down this line, this is joining 2 4 and 4 6. See, this is 4 6, this is 2 4. So joining and extending. Next we have 1 2 1 6. So again 1 6 is at infinity, so you have to draw a line from 1 2 to infinity. Now if you draw this direction, it will not meet, so the possibility is only on the downward direction. So downward the direction, so it will meet at this point. This will be your I26. Okay, then next we have 2 5. Now here see the diagram. If you want to locate 2 5, you have to take two combinations with 2 and 5. First I will take 1 2 5. If I take 1 2 5, what are the three links in that? 1 2 1 5 and 2 5. So 1 2 is here, 1 5 is here, then we can locate 2 5. Next takes the other combination. After 1 we can take 2 3 5. If you take 2 3 5, 2 3 is known, the centers are 2 3 3 5 and 2 5, but 3 5 is not located. Here you can see, therefore you have to use 2, you cannot use the combination with the 3. Now you take 2 4 5. If you take 2 4 5, the centers are 2 4 4 5 and 2 5. So that is possible because we located both 2 4 and 4 5. So that is one combination, 2 4 4 5. So you can locate 1 2 5 and 2 4 5. So 1 2 5 means you have to join 1 2 and 1 5. So this is, you are joining 1 2 and 1 5. Then 2 4 5 means you have to join 2 4 and 4 5. So 4 5 is this point, C, 2 4 is this point. So you join both and extend up to this line. Here you can see, here it will meet. That will be your 2 5. Clear? So 2 5 is also located. Then next we have 2 are remaining, 3 5 and 3 6. Now you see how will you locate 3 5. To locate 3 5, again you have to take combination. You can take a combination. First you try with 1. So 1 we are taking 1, the combination will be 1 3 5. So in case of 1 3 5, the centers are 1 3 1 5 and 3 5. So we have 1 3 located, 1 5 also located. Then you can use that combination to locate 3 5. So note it down, 1 3 5. Then next you take 2 3 5. If we take 2 3 5, the centers in 2 3 5 are 2 3 3 5 and 2 5. So 2 3 is located, 2 5 also located. Therefore we can use that combination also for locating 3 5. Now you joined 1 3 and 1 5 and also 2 3 and 2 5. So 1 3 is this point and 1 5 is this point. So joining 1 3, this is already a line, you can extend it in both directions. Then we have 2 3 and 2 5. So you have to join 2 5 and 2 3. So the problem, when you join 2 5 and 2 3, it will go like this. If you join 1 5 and 1 3, it will go like this. So this will not, this cannot meet in the screen. So I will show another diagram. Scale down, the diagram will be scaled down, or the size I will change, and I will show it the locating, how to locate 3 5 and also 3 6. Okay, wait. Before that, I will locate 3 5 cannot be located here, but 3 6 we can locate. That is the remaining thing. So 3 6 I will locate in the same diagram. Then I will show 3 5 in another diagram. So how will you locate 3 6? You can choose the combination of 1 3 6. If we take the combination 1 3 6, centers will be 1 3 1 6 and 3 6. So 1 3 and 1 6 are located. So then you draw, you locate 1 3 to 1 6. So line to infinity will be that line. Then next we have, in case of 3 6, we can choose the combination 3 4 6. If we choose 3 4 6, then combination the centers are 3 4 3 6 and 4 6. So 3 4 and 4 6 are located. So you have 3 4 here, 4 6 here. So you can join both. So I join 3 4 to 4 6 and extend to meet this line. So this will meet it here, and this will be your 3 6. So the only remaining one is 3 5. So I said how to locate. I'll show it in another diagram. So here you can see the same diagram, which is only 3 5 is not located. So if you to locate 3 5, you can extend 2 5 and 2 3 and 1 3 and 1 5. So both will meet at somewhere very far. That is your I 3 5. Okay, that's all. Now we'll see how to this is how to locate instantaneous sender. So there will be one more method. If you cannot manually find the combination, if you find a difficulty in combination or manually, that is if you have to find 2 5, you have to use the combination 1 2 5 2 3 5 like that. If there is any difficulty, there will be a easier method. It is called using a circle. That I will that also I will show. So then next will be a problem. That means how to use this for velocity analysis. Okay, so this is a problem. And the same diagram here, you have to do a velocity analysis. So all details are given, the question, all dimensions are given, also the inclination for you to draw. So first you have to draw the space diagram. So the question is locate all in the instantaneous centers. That we already done in the same diagram. Then the next part is, if crank rotates uniformly at 120 rpm, find the velocity of B, C and D, angular velocity of links A, B, B, C and C, D. So velocity of points B, C and D, these 3 points, and links A, B, B, C and C, D, these 3 links of you have to find. So step 1 is draw the space diagram. So you have to draw the space diagram in book. So when you draw, make sure it is, you already saw that where all the centers are located. So like that you have to draw. That means there should be sufficient space around the diagram to locate all the centers. You can accept 3 5. 3 5 is to locate 3 5 you need a very large space. That is not possible. So 3 5 you can skip, but all other center you should be able to locate in your diagram. 3 5, instead of locating, you just draw 2 lines and write it. It will, the meeting point will be 3 5. Okay, but all other centers you have to locate. So accordingly you have to draw. That is the first part I am telling. Then this is the next part. You have to again draw, because it's better advised to draw again for better understanding of the analysis. So the solving problem and locating instantaneous, all centers are different. To locate all centers, we are go through all the possible ways and locating all the centers. But in case of a problem, we need to locate only specific centers. So should not locate any other centers. Then it will be helpful if you draw another space diagram. So first step is drawing the space diagram. So we have the space diagram, and here check the input. If crank OA rotates at 120 rpm, so OA is your crank and the velocity or the details of crank speed is given, that is your input. So if you are given that OA rotates at 120 rpm, what we can find is omega of OA. Omega of OA will be 2 pi n by 60. You will get omega. Then from that you will get the velocity of point A. So VA you will get. That is the first step and common to both velocity analysis and to this is common to velocity analysis and as a relative velocity method and instantaneous center method. So you find VA. So write VA is how much. Then you will continue. Now this is our diagram. Next read the question. In the question what you have to find is velocities of point B, C and D. Now we have the velocity of point A. Okay. Then we have the velocity of point A. We have to find the velocity of point B. Then what you have to check? You have to check A and B belongs to which link. So this is common to which link? 3. Link 3. So which center you have to locate for that? I13 only. So you have to locate I13. So we already located in the previous diagram. So I will again show it. After locating permanent centers and fixed center. So we located 1 3. So if I located 1 3, then what I can say, what I can write, this 1 3 is the instantaneous center of link 3. Therefore I can say velocity of A divided by I13A, this distance, will be equal to velocity of B divided by I13B, this distance, I13 to point B. Okay. And this will be equal to what? The velocity divided by distance, center distance will be equal to your omega of 3 or omega of AB. So that's expression you have to use. This expression you have to use. Here VA is known, I13A, that distance, I13B, both distance you have to measure. Once you locate that your I13 in your diagram, you have to measure it and write it here. Then you will get VB. So now you found VB, determine the next, the same expression. If you have VA and 13A, I13A, so just that find the ratio, otherwise VB by I13B, that ratio will be your omega AB. That is also in the question. You want to find the angular velocity of AB. So you find that also. So you got VB and omega AB. The next part is you have to find velocity of C. Now you see we have point B, velocity of B now in hand. Then we have to find velocity of C. So B and C are related to which link? Fourth link. Therefore, which center you have to locate? I14 only. And I14 is actually a fixed center. Therefore, we don't have to locate it again. That is already there in your diagram. This point E is your I14. Okay. Then how will you write the expression? VB divided by I14B, this distance, B to center distance, equal to VC divided by I14C, C to center distance. That will be equal to omega of BC, fourth link. Okay. This expression. So here VB is known from this expression. Now I14B you have to measure this distance BE, that will be your I14B. Then I14C, distance CE, measure both and then you will get VC. Also you can find omega BC. So you got VC and omega BC. Then last part, we will come to after C, question is velocity of D. So C and D are parts of belong to which link? 5. Therefore, we know the velocity of C. So we have to find the velocity of D. Then you have which center you have to locate? I15 only. So you locate I15. Okay, this is I15 already there in previous diagram. The next you have to write the expression. What you can write? The link is CD and center is I15. BC divided by I15C, that is this distance C to I15. This large distance you have to measure, equal to VD divided by I15d, this vertical distance, okay, I15d equal to omega of 5 or omega of CD. That expression you have to use. This expression VC is known from the second equation, set of equations. Then I15C you have to measure this distance. I15D you have to measure. Then you will get VD and omega CD. Clear? Like this you have to continue. So you need to locate only two secondary centers for the solution of the problem. Clear? So you should not, when a question is given and to find only the velocity using instantaneous center method, you should not try to locate all unwanted centers. All primary centers you can locate, because that is required for locating another secondary center. But secondary center, when you locate only required centers. Okay, so here I located only two centers. This is only required, no other center. So the diagram will be simple and you will understand. Okay, then answers are given. Approximately these answers you should get. Okay, VA is an input only. VA will be, you will get a 2.514. Then VB, VC, VD and omega of all. Okay, so this is how velocity understand for a 6-link mechanism. So as I told that locate instantaneous center, there is a method using a circle that I will explain the next lecture with another diagram. Okay, those who are find difficulty in manually doing here, you can use that also. So thank you.